Hello students, we'll move on with the next project that is given to you in this particular chapter, that is an organizing file. The project is called backing up a folder into a zip file. So here what they're saying here is we might be working on a project and we are going to save the files in a folder, and we'll name that particular folder as C:/ Python book. So we are saving in that folder, but there might be a possibility wherein we might lose our work. So what we would do here is we would like to create a zip file snapshots of the entire folder. So we would like to keep different versions. So we want the zip file names to increment each time it is made. Okay, every time a zip file is created, we want a incremented file name than the previous one. So any modification you have done, then when it is saved, it should be saved in the incremented uh, file name should be an incremented value. Okay, so suppose if the file name is Python book, first it will be Python book 1.zip, next time Python book 2.zip, like this it should go on. Okay, so this can be done manually, but what happens is there might be a possibility wherein we might misnumber the zip files, so that can happen. So for that purpose, here we are saying that why not we have a program for that. Okay, that is, we are having a Python program which is going to do backing up, which is going to back up a folder into zip files. So again, it is given step by step. We will see each step by step. Okay, so in the first step, what we are saying, figure out the zip file names. So here we are going to get the zip file names. So how will be the zip file? They will be in the incremented order. Okay, so if the first zip file is Python book 1, next one will be incremented, that is Python book 2, like this, Python book 2.zip, like this it goes on. So here first of all you have the shebang line wherein you're telling that it is a Python program. Then after that you have written the comment section wherein you're telling what this particular program is going to do. So also you also told the name of the file here, that is backup to zip.py. So what it is going to do, it is going to copy the entire folder and its content into a zip file whose file name increments. Okay, it is having an incremented file name. So to begin with, we are going to import the module, that is zip file and OS. So that is the first thing what we will do. And the next part what we have here is we are defining a function. So the name of the function is backup to zip. Okay, and this particular function is going to take a parameter. So that parameter is nothing but a folder. So this parameter is a string path to the folder whose content we want to backup. Okay, so that is nothing but, you can see here at the end we are calling this particular function backup to zip, and just see what is the parameter you're passing. You're passing the string path to the folder which you want to backup. So which is the folder you want to backup? You want to backup this particular folder whose name is delicious. So the file names, the what we can say, the zip files what you're going to create, it can be delicious 1.zip, delicious 2.zip, like this it goes on. Okay, so in general we can say the zip files can be named as delicious underscore n.zip, wherein that n value will range as 1, 2, like this it goes on. Every time when you're running, that n value will be incremented. That is what we are giving here. Number is equal to number plus 1. So we'll just see what is happening inside this backup to zip. So within this backup to zip, we said that we are going to pass the string path of the folder which you want to backup. So this function is going to determine what file name to use for the zip file that will be created. Okay, so after that the function, the next part is you're going to create the zip file. Then after that, the next thing, we are going to walk through the entire folder tree and compress the files in each of the folder. And finally we'll be printing the print done. So all these things, these two parts we are writing in to do section, which will be in the next steps. Okay. So here we are speaking about the first part wherein you are going to name the zip file. Okay. So naming the zip file, it uses the base name of the absolute path of the folder. So here you can see what are you going to do? Backup the entire contents of the folder into zip file. So here you're going to get the absolute path of your folder which you want to backup. So that will be stored in this folder. Next thing what we want to do, we want to figure out what name you should give to the zip file. Okay, so we said how should be the zip file. So here the name of the folder which you want to backup is delicious. So zip file should be delicious underscore n dot zip. So that n value will be 1, 2, like this it goes on. Okay. So for that purpose, we have given the number equal to 1. We have initialized as 1. So first time when you're running the program, then your zip file name will be delicious underscore 1 dot zip. Okay, so like this it goes on. So naming the zip file, it uses the base name of the absolute path of the folder. Okay, so here in our case the folder name is delicious. The zip file will be named as delicious underscore n dot zip, where first time running n value will be 1, next time running n value will be 2, like this it goes on. Okay, so by doing this we will understand whether that particular file is already there or not. That is what is happening inside this. Okay, so here you can see number you have initialized to 1, then while true, what you're going to do, you're going to get the absolute the base name you're using, and you're checking, so that is stored here in the zip file name. If not os.path.exist, you're checking whether that file name is already there. Okay, so suppose you have delicious 1.zip. So you're checking whether that particular file name is there. If it is already there, then if not, os.path. So what you're going to do here, you're checking for the existence. Okay, if delicious underscore 1.zip already exists, then check whether delicious 2.zip whether it exists, and again you're going to check whether 3.zip already exists. So that is what is happening here. Okay, so for this purpose we are using a variable number for that n. So this number is nothing but delicious 1, that 1, 2, or delicious 2 dot zip, delicious 3 dot zip, like this it goes on. That is nothing but we can say as n. So for that purpose we have used, for that n we have used a variable called as number, and we keep on incrementing it inside the loop. Here you can see inside the loop which calls ospath.exist, check whether the file name exists. The first non-existence of the file name. If the file name does not exist, then it is break, since it will have found the file name in the new zip file. Okay, if it is not, then break, otherwise you're just going to increment the file name. So what is this incrementing? So we found that delicious 1.zip is there. Then what you should do? Again, new updation should be delicious 2.zip. That is nothing but the incrementing what you're doing here. Okay, so like this it goes on. New files will be named over here. Okay, so named, how you're going to name. So here the folder you have which you want to backup, you have passed as delicious. So your zip files will be delicious underscore 1.zip, delicious underscore 2.zip. That is what is told here. Okay, so base name here is delicious underscore, you can see here. So base name is delicious followed by underscore, and this number, what is this number? That is nothing but initially it will be 1, then after that it will be 2, then it will be 3, like this it goes on. And this after that extension is dot zip. That is nothing but your zip file. Okay, so that is given here. This plus is nothing but just a concatenation operator what you have used. So what are we doing in this part? We are naming our zip file. Okay, and in the next step what we are going to do, we are going to create the zip file And after that, next step, we are going to walk through the entire folder tree and compress the files of each of the folder. Okay, so in step 1, what we are going to do, we are creating or we are giving the name for the zip file. So how we are going to give, we are considering the absolute path of the folder which you want to backup, and that base name underscore base name underscore the number initially you have made it as 1, and you're checking whether it is there or not. Okay, so if delicious 1 dot number is there, then what it means, the next name should be delicious 2 dot zip. So that is nothing but the incrementing what you're going to do here. Okay, so that is naming your zip file. Next step, that is step 2. What are we doing in step 2? What we are doing here is we are going to create the new zip file. Okay, so all this already we saw. So only thing what we are going to do here is, that is the thing what is given inside bold, whatever is written in bold. Okay, so here what we are going, so we are going to create a new zip file. Okay, so new zip file name will be stored in this zip file variable. Okay, so now you can call zip file dot zip file to actually create a zip file. So what does this do? This is going to create a zip file with what name? What name you have passed over here? That name, that is delicious underscore 1 dot zip. That is for the first time. Okay, so you're going to create, so zip file dot zip file is going to create a folder, that is your create a zip file. And in what way it is going to create, that is the second argument what you're passing, that is you're going to create a zip file in write mode. Okay, that is W is nothing but the write mode. And after that, what will be the next part you have to do, that is given in this to do section, that is you have to walk through the entire folder tree and compress the file in each of the folder. That is the next step what we have to do, that is given over here. The third step what we are doing again, so this is the thing what is written in bold, so that is the thing what we have to write for the third step. So in third step what we are going to do, we are going to check all the folders, subfolder and the files also. So for that purpose we are using OS walk. You can see here OS walk within the bracket folder you have passed. So OS work function, what does it do? It is going to list every files in the folder as well as in the subfolder. So this OS work we have already seen in the previous session. So it is going to list all the files as well as subfolder, and within the subfolder whatever files are there, everything will be listed. So you can see here for folders, subfolders and files in os.walk folder. So which folder you have given, you have given c colon slash delicious. So within that whatever files whatever folder subfolders you have, and within that subfolder whatever files you have, everything will be listed. Okay, so that is os walk which is written inside for loop, and on each iteration it is going to return the iteration's current folder name. So first iteration, if it is delicious, so you can see the result here. First is delicious, and inside delicious you might be having a folder, or you're having a folder called as cats. So that folder name is displayed. Okay, so what is this os dot walk function going to do? On each iteration it is going to return the iteration's current folder name, and also the subfolder in that folder and the file names in that folder it is going to return. Okay, so in the for loop the folder is added to the zip file. So that is what here you can see here, add the current folder to the zip file. So what you're going to do within the for loop, what is happening, the folder is added to the zip file. Then the nested for loop can go through each file name in the file names list. So every file that is file name in file name. So every file in the file name list, it is going to walk through all those. Okay, so each of these is added to zip file. It is added, but you're also checking whether it is already there. That is, you can check, see here, don't backup to backup zip file. What you don't want to backup, which is already there, don't backup it. Okay, so which is not present previously, that thing you have to backup. So you can check here, if file name dot start with the new base and file name ends with zip, means if it is already there, then you're simply going to continue. Otherwise, what you're going to do, you are going to write. Okay, so here path dot join is nothing but it is going to join that particular file name to the path. Okay, so finally you're going to close the zip file and you're going to print done. So at the end, you can see here we are calling the function backup to zip, and what is the parameter you're passing? That is the absolute path here. So this is how your result is displayed. That is creating delicious one dot zip. So this is first time when you're running. So first time when you're running, you're adding to this particular zip file, delicious, cat, waffle, all those things it is done. Next time again you're running. Suppose you assume next time you're running it again. You have made some modification and you're running it again. That time what will happen? Creating delicious two dot zip will be done. Okay. So that where it is happening, that is over here, right? Number is equal to number plus one you're doing. So that time what happens? It will be delicious two dot zip, and again all these files will be added. Once again, then it will be number 3 dot zip. So like this it goes on. So this is about your project, that is you are backing up the folders to zip file. Okay, so with that we are done with the third chapter of module 3. Okay, so the next chapter is debugging. Okay, so in module 3 you are having 4 chapters from the textbook. So this is the fourth chapter, that is debugging. So next we'll go on, we'll move on with the debugging. So in the previous chapters, we saw few programs. That is, we cannot say it as very simple program because we have seen many projects. So some complicated programs. So it can happen that during this program we might come across some bugs, right? Or errors also you can say. So how to fix them, that is what we are going to see in this particular chapter. Okay, so what we are saying here is your computer will be doing only that what you are telling it to do. So it won't do something on its own, right? So it won't read your mind and do what you intended to do it. So it is going to do only what you are telling it to do. So even the professional program or also he might create some bug at some point or the other. So we should not discourage, we should not get discouraged if our program is having some problem. Okay, so we must try and debug it. So that is what we are going to see. So here in this particular chapter, we are going to see few tools and techniques to identify what exactly your code is doing. Okay, and where we have gone wrong. So first part we will be going to see about logging and assertions. So two features that help us in detecting bugs early. So the earlier you detect your bug, or the earlier you catch the bug, the easier will they be to fix it. Okay, and the second part what we are going to see is about how to use the debugger. Okay, so we have already seen how to work with the IDLE. So now in this particular chapter we are also going to see how to use the debugger. The debugger is a feature of IDLE that executes a program one instructions at a time. Okay, so it gives us a chance to inspect the values in variables while the code or while you're running your code, and also track how the values change over the course of the program. So using this debugger, you can get all this information. So this is Other thing is it is slower than running the program at full speed, but it is helpful to see the actual values in the program when it runs, rather than just deducing what the values might be from the source code. There's a better way. You will get to know how the values keep on changing. So that is what we are going to see in this particular chapter. Okay, so we'll begin with the first topic, that is raising exceptions. Okay, so about exceptions, I hope you all know, right? So I think you have already learned in your OC about try catch, that is your exception handling techniques wherein you use the try and catch blocks, all those things, right? So here Python raises an exception whenever it tries to execute an invalid code. Okay, so you have an invalid code. If you're trying to execute that, then exception will be raised. So in the previous chapters we had seen how to handle Python exception with try and except statements. In OC you had learned try and catch. Here in the chapter 3 probably there we had learnt about try and except statement, so that a program can recover from the exception that has occurred. So even though exceptions is there, your program is still able to work. But you can also raise exceptions on your own in your code. So here raising an exception is a way of telling stop running the code in this particular function and move the program execution to the except statement. That is what here the exception, raising an exception mean. Okay, so exceptions are raised with the raise statement. So in code, a raise statement consists of the following. You have the keyword called as raise, a call to the exception function, and a string with the helpful error message passed to the exception. So we'll see what is the meaning of this. So we will go to our IDLE. So I'll just open our shell. So you can see here, this is a Python. Okay, I hope this is visible. So we will see how we can write our own exception, okay, using the raise keyword. So I've written raise. So what was told, a raise statement consists of the following. So first of all you have the keyword called as raise, then you have to call the exception function. So we'll write exception, and within that function a string that string with the helpful error message is passed to this exception function. So some string I'll write, this is an error message. Okay. So how you can raise an exception? By using the keyword raise and call the exception function. And what are the parameters you're passing to the function? That is any string that is with the helpful error message. So here what is the error message? This is an error message. So this is how you can raise an error in your program. Okay, so you can see here here the traceback is there, and whatever string you have passed here within or for this exception function, that is this is an error message, so that is displayed here. Okay, so if there is no try and except statements covering the raise statement, that raised exception here, the program simply crashes and displays the exceptions error message. That is what here exception, what you have passed to this exception function, that is this is an error message. So what happened here, I just wrote the raise keyword followed by the exception, and I wrote some statement here, string message, right? So here we have not used the try and except statements. So whenever there is no try and except statements, the program simply crashes, and when it is crashing it is just displaying the exceptions error message. So here what is the error message here? This is an error message, so it is just displaying that particular message and it's going to come out of the program. Okay, So the code that so it can usually what happens, the code that calls the function uh, knows how to handle that particular exception. So usually we will write the exception handling, right? So we will commonly see a raise statement inside the function and the try and except statements in the code calling function. So usually we will have try and except statements. That is why, to handle the exception. So if you have not written the try and except statement, then what happens? The program just crashes, displaying this message, that is whatever you have passed to the exception. Okay. So we have an example program here. So this is what we saw just now. We have an example program, that is boxprint.py. So we'll just see that particular program. Where is it? Okay. So we have this program, that is box. I have named it as box.py. Okay. So what you're doing in this particular program is, we are using a function called as boxprint. Okay. And what are the parameters you're going to pass? You're going to pass the symbol, whether you want a star, or whether you want character O, or whether you want X or Z, and what you want, that is nothing but the symbol followed by width. So here what we are going to do is, in this particular program we are going to print a box pattern. Okay. So for this to print that box pattern, what is the symbol you want to use, and along with that, what will be the width of that box and what will be the height of that box. So these are the parameters which the box print function is going to take. Okay. So that is what we have defined here, box print. And the parameter it is taking is the character. Here the character is nothing but, we have named it as symbol. Okay. And width and height. So here using the character or the symbol, whatever you have used, using that the box will be printed. Okay. So we want a character to be a single character and the width and height to be greater than 2. That is what the constraint we are mentioning here. So length of symbol, here symbol can be a star, O, X, double Z. So length of symbol should not be equal to 1 in case if it is not equal to 1. So you should give 1 only. Okay. So for that purpose you have written not equal to 1. So if it is not equal to 1, then what happens? You are going to raise an exception. What is that exception? Symbol must be a single character. So what did we say here? I'll just run and show you this code. See, this is what the output is. So this is what we want to print. Okay. So just see here, the first symbol what we have given is star. The next symbol what we have given is O. And what is the width we said? Width is nothing but this. Here the width is 4. And height is nothing but this. Whatever height you get, that is the height. Okay. So this is what you want to display. Okay. So for that we have written the code. We'll just see the code here. So length of the symbol should not be, if the length of the symbol is not equal to 1, then in that case what you're going to do, you're going to raise an exception, and this error message what you're going to display, symbol must be a single character. Because why? Here, if you have given more than one character, so here width you might have told us 4. Okay. So in this case, just see here, width is 4. But instead of single character, if you have given as 5 star, 5. If the number of character you have given as 5, that is nothing but here. Here if you would have given 5 stars, then just see what would happen. See here, in this case, here it is an error here. So what would happen if you are given more number of stars? Those many number of stars will be displayed, right? So that time the width won't be correct. Whatever width you have given, it won't be aligned properly. So for that purpose here, the conditional statement what we have given, so I'll just, if you want, I'll comment it. Okay, in this comment it and see. Here instead of star, I'll give 4 stars. So just see here what happened now. Instead of 1 star, I gave 4 star. So just see here that box pattern is not appearing here, right? So there is no pattern coming here. So for that purpose here, what we are telling is the length should be equal to 1. So if it is not equal to 1, then you're going to raise an error message. Similarly, width should be less than, not like should be. If the width is less than or equal to 2 or height is less than or equal to 2, then what you're going to do, you're going to raise a exception saying width should be greater than 2. Even height should be greater than 2. Okay. So this is all the exception condition you're writing here. So what is the exception condition? Symbol should be only 1. So if you have given more than 1, then you're going to raise an exception. Width, if it is less than or equal to 2, again raise the exception. Height, if it is less than or equal to 2, again raise the exception. Okay. So if none of them are there, the next part what you're going to do? You are going to print, what are you going to print? You're going to print the symbol into width. So just see here the first part. The symbol I've given as star. What is the width? Width is 4. So star into 4. So how many stars you're going to get? You can see here you got 4 stars. That is nothing but the symbol star followed by width 4. Okay. So that will be printed. So after that you are using a for loop here wherein you are checking for the height. Okay. So height is 4. Height is 4. So just see the range here. Range here we are giving as height minus 2. So starting from 0 you're going till 2. So you're printing the symbol. Symbol is star, right? And you're using the concatenating symbol. Concatenating operator here. So within that what you're writing here? A space. Okay, so here opening and closing quote is nothing but a space into width minus 2. Width minus 2. What is our width? Width is 4. 4 minus 2 is 2. That is nothing but this particular part. What it is saying here is give 2 spaces. Okay, so how will be your print? So just run it. See, when you're running, you can see here one star is printed, and after that you have 2 spaces. So here one space, here one space. Then again, star is printed. That is what is happening here. Plus symbol. So what happened? First one symbol is printed. After that you have space. How much space? 2 spaces. How you got that 2 value? Width is 4. 4 minus 2 is 2. Okay. So in the next example you can see it is 20. Width is 20. 20 minus 2 is 18 spaces. And after that again the symbol will be printed. Okay. And what is this part? Symbol into width. That symbol into width is nothing but you are printing that symbol 4 times. Okay. So this is what is your code wherein you are displaying a box pattern. Okay. So again you can check here for symbol width and height. Okay. In. So you're passing the pattern. Whatever characters you want to use in your pattern, you're going to pass here. Okay. So in the try block, you're calling the function box print. You're passing the symbol width and height. So for the first case, no problem. Symbol is star, width is 4, height is 4. So what did we say? Width should not be less than or equal to 2. Height also should not be less than or equal to 2. And symbol should be 1, right? So if it is not equal to 1, it is raising an error. So if you are given any symbol greater than 1, then it will be a error. So first time box print, this parameter will be passed. So what is the output you got for that? You got this as a output, that is star, right? So next time when you're calling this, it'll loop, right? So next time again call the box print. Now the parameter you're passing symbol is O, width is 20, height is 5. So what is the output you got? So what is the output you got? So this is the output, just see here. So the character here is O, width is 20. So here width was 4, right? Here width is 20. So you got these many number of zeros. And what is the height? Height is 5, right? So height is 5. So that is nothing but here you can see here 5 minus, you can see here height minus 2. So 5 minus 2 is how much? 3. So that is what here, height is 3 here. Okay, so 5 minus 2 you got here, you got that output. Next time what happens? Again you are, next iteration, the symbol is x, width is 1. So for this no problem, only one character, but just check the width here. So what we have told, width, if width is less than or equal to 2, then you're going to print or you're going to raise an exception saying width must be greater than 2, right? So that is what you got here, exception happened, width must be greater than 2. Again the next case, ZZ. So what did we say? Symbol should be only 1. If it is not equal to 1, then there is an exception. That is, symbol must be a single character. And after that, width you have passed as 3 and height you have passed as 3. Okay. So what happens in this case? Again, exception is occurred, right? So exception happened. What kind of exception? That is written in your ERR. So what kind of exception has occurred? You have given the symbol 2 characters. Your symbol should be only 1 character, but here you have passed 2 characters, right? But it is okay. So here you have passed 2 characters. So you're getting this message saying symbol must be a single character string. So this is your program, that is box program. Okay. So that is all about your exception, that is raising exception, and with an example program, that is boxprint.py. Okay, so that is what you have to tell for raising an exception. Next we'll move on with traceback, that is getting the traceback as a string. So when the Python encounters an error, then it gives some information about the error, so that you can call it as a traceback. So this traceback includes the error message, the line number of the line that caused the error, and the sequence of function calls that led to the error. So it is going to give you the complete details of the error, which line it has occurred, what was the error, and which function has the sequence of function call. That is, uh, you might have called a function, and when you call that function, you're going to the definition part of that particular function. So there some error might have occurred, or within that definition part again you might have called another function. So in that definition part there might be an error. So all those information will be displayed. So we have an example program for that, which is telling us the sequence of function call that led to the error. Okay, so this sequence of call is called as the call stack. Okay, so what is traceback? So the Python program, whenever error has occurred, the information what it is giving, it is called as traceback, information about that error. So this traceback means it includes what is the error message, also the line number that caused the error, and also the sequence of function call that has caused the error. So this sequence of call, you can also call it as a call stack. So we'll just see the example program related to this. Okay, so you can see here, here we have an example program, that is we have two function definition, that is spam and bacon. So first what happens, you're calling the function spam. So when you're calling the function spam, again it is going to come over here, and from here you're calling one more function, that is bacon. So when you're calling the function bacon, you're going to the definition part of bacon. In the definition part, what you have a raise statement, that is exception statements, that is raise exception. What is the error message given there? This is the error message. So what did we say in traceback? It is going to tell you the line number where the error has occurred. Also, it is going to tell you the sequence of function call which has raised that error. We'll just run this particular program and just see. So just see here. So you can see here. So we are just running this program. Okay. So you can see what are the errors. So you have one error in line number 5, line number 2, line number 4. So it is going to give you the sequence of function call that has raised the error. So you can see line number 5, what do you have? You have spam. So from here you call the spam function, right? So when you're coming over here again, you're going to the definition part. So here you encountered the error. So that is what we said here. That is includes the error message. So what is that error message? So that also was told over here. What is the error message? So this is an error message. So whatever is written inside the exception function, that string that will be displayed. Okay. Along with that, line number which caused the error and the sequence of function call that led to the error. So what is that sequence of function call? We had spam. From spam, that is in line number 5, we had spam. From spam we went to the definition, and inside the definition we had bacon, and again we went to the definition of bacon, and inside that you had the exception. What is that exception? That is the string what you passed inside this exception. That is, this is the error message. So complete details will be displayed. So that is about the that is trace back what we said. So this sequence of call, you're calling it as a call stack. Okay. So we have one more example here. I'll just see here. That is table 2. So we have one more example over here. So here we are importing. So what happened here? We saw traceback is going to give you the complete details of where what error has occurred, right? So the traceback is displayed by Python whenever raised exception goes unhandled. Okay, but you can also obtain it as a string by calling a function that is called as traceback dot format dot exe. Okay, so you can obtain the string by calling this particular function. So this function is useful if you want the information from an exceptions traceback, but also you want an except statement to gracefully handle this exception. So we'll just see what is the meaning of all this by executing this particular program. So what is happening here? We want that information about that. Okay, so that can be got by using this traceback.format.exe. Okay, so we want to obtain the raised exception in the form of a string by calling this traceback.format.exe. So here we have to include, that is we have to import the module that is traceback. Okay, so what happens here, instead of crashing your program when an exception occurs, you can write that traceback information into a log file. Okay, so that is your error file dot write. So we are writing. So first of all, in the except part, that is here an error, that is in try block you're writing the exception. Okay, so when the exception has occurred, what should be done? What should be done here? This is an example which is telling that the information is written into another file. So here, what is that file? That file name is errorinfo.txt. So we are opening that file in the write mode because we want the details to be written in this file. Okay, and that handler is your handler is named as error file. Next, what you're doing, error file dot write. You're using this function that is traceback dot format what you're doing, you can obtain the data as in the form of a string. So for that purpose you're calling this function, and after that you're closing that file handler, that is error file dot close. Then in your ideally you'll be getting a message saying that the traceback information was written to error info dot txt. So we'll just see what is happening. So what did we say? Exception has occurred, and in the except block, what you're telling that the details you write it into another file. The name of the file here we have given as errorinfo.txt. Okay, so we'll just see what happens. We'll just run this particular statement, sorry, program. So just see here, what is the statement that is printed? The statement that is printed is the traceback info is written to errorinfo.txt. In the previous case, what happened? The complete information was displayed here in your IDLE. Now we don't want that. We want the information to be written into another file. Okay, so in your IDLE you just got this information. Now you can just check out, we can go to the path where we have saved. So I'll just go over there. I'll give file, open, and what is the name of the file? That is error info.txt. So you can just see, I will give here the name of the file error info.txt. So I'll just try to open that particular file. So you can see here in error info.txt, you're having that information about the exception. So here what has happened, the information related to that exception that has occurred, that trace back whatever information it is going to give. In this case it is not displayed in your IDLE, but it is written into another file. Okay, so this example is saying, so if you want to check out the details of the file, then you can just go open, and whatever file name you have given, you have to just give that particular file name. Here the name of the file is errorinfo.txt. Okay, so this is all about your traceback.